Hello, and welcome to a little video about identifying exponential growth and decay. Okay, so at this moment, the population of downtown is 20,000 people. The population of uptown is 6,000 people. But over many years, the people have been moving away from downtown at a rate of 1.5% every year. At the same time, uptown's population has been growing at a rate of 1.8 each year. What we want to do here is identify the independent and dependent qualities of this situation. Think about it. What is independent? The time that passes, or is it the population? When we're talking about independent quantities, time is always independent. So in this case, years. That means dependent is our population. Because the population of our town depends on the amount of time that has passed. Let's think about what's increasing and decreasing. Uptown is gaining people, downtown is losing people. So increasing will be uptown and decreasing would be downtown. And here are graphs. Now if you take a look at downtown's graph, we have, or function, we're starting with the starting population, decreasing is the minus, and then our rate is written as a decimal. Same thing goes with uptown. We start at 6,000 people. We're increasing our population, so that's plus 0.18. That's our rate. Now, usually the way I like to represent our function is A equals amount. P is our starting population or starting amount. 1 plus minus, depending if it's increasing or decreasing. R is our rate. T is our time. Here's a little sketch of the downtown and uptown graphs. The downtown graph has a y-intercept at 20,000 and then it decreases. Uptown, however, has a y-intercept at 6,000 and it increases. This is something that I showed you in class. Again, I can't record two screens at once. I'll figure that out someday. But at the moment, I just know how to record one at once, so one note is the one being recorded. All right, number 4. What is the a value of each function? Now, the a value is this first term. Now, if we take a look at number 3, we started with 20,000. That's the population of downtown. 6,000. That's the population of uptown. Notice that there also are y-intercepts. So, A is the starting point. In this case, it's our population. And it's the y-intercept. The b value. Well, the b value is our growth and our decay. And we saw it in parentheses up here, but this is our b value if we actually did the addition or subtraction. So b is percent growth, which would be 1 plus r, or percent decay, 1 minus r. And let's kind of, compare b's here because we have the 1 plus and the 1 minus. The 1 minus is our decay. And if we actually do the subtraction, we get 0.985. That's a number smaller than 1. It's decaying. If we have the 1 plus, that's our growth. And if we do the actual addition, we get 1.018. And that would be our growth. Now, number 5 asks us what we had in number 4 again. So I'm just going to talk about it instead of writing things down. The y-intercepts are our a terms for number 4 and number 3, so 20,000 and 6,000. The meaning of our y-intercept, we wrote that down in 4a. That's our starting population. And, whoops, how can we tell where the y-intercept is? We can take a look at A. And how can we know if it's increasing or decreasing? Although that doesn't ask us that in 5C. We look at the plus or minus, or we look at if it starts with 0 point, that's decay. 1 point, that would be growth. Because if you're subtracting from 1 for decay, you're going to get a 0 point something. And if you're adding for growth, you're going to get something bigger than 1. Okay. Let's write some functions. Blueville has a population of 7,000 and it's increasing at a rate of 1.4. The starting point, the starting population is 7,000. We are increasing, so that's 1 plus. 1.4 as a decimal, in order to get this percent to be a decimal, we divide by 100. So 0.014 to the power of x. All right. Greenville. Greenville starts with 7,000. It's decreasing 1 minus at a rate of 1.75%. If we divide that by 100, we get 0.0175. Starting population, decreasing, and our rate as a decimal. Youngstown has a population of 7,000. The population is increasing at a rate of 0.012 or 1.2%. North Park. North Park starts at 7,000. The population is decreasing at a rate of 3.1%, so that's 0.031. Let's check out Westlake and Springfield. Westlake. Westlake has a population of 7,000. The population is growing at 2.8%, so that's 0.028. 7,000, increasing 2.8%. Let's do Springfield. Springfield starts at 7,000. Its population is decreasing. And 1.25% as a decimal is 0.0125 to the power of x. Now, if we ever wanted to actually calculate the amount of the population after any amount of years, we would plug this into our calculator and we would put a number instead of x. All right, that's about it. That's all I have for you for exponential growth and decay. If you have any questions, please make sure to ask myself or your teacher about this. Have a wonderful rest of whatever day it is for you. Bye!